Okay, so here we have a problem. Determine whether the sequence if n converges or diverges. Then see what it converges to if it does converge. Alright, so we have the sequence is equal to n squared times cosine of n, 1 plus n squared. Okay, I'm going to write this instead as cosine of n times n squared over n squared plus 1. Okay, so let me first analyze how this works. Now, basically, we want to find out what happens to these terms, okay? Or in other words, the sequence as our n goes to infinity, right? That's what it means to converge or diverge. We check the behavior as n goes to infinity. So let's check this. Let's check what happens as n goes to infinity for this term. As n goes to infinity, for this term here, we can do a lot of things actually. First of all, we can see that this basically approaches 1. Now, why is that? Well, there's multiple ways for us to prove it. First of all, I can say this is the same as factoring out an n squared, and then I get 1. Or really, okay, we can multiply the top and bottom by n squared, right? So this is what I'll get. I'll get n squared over n squared times n squared. Then this will be multiplied by n squared over squared plus 1. Okay, and then this is the same as these two canceling out, so I get n. Then I get on the bottom, basically what we can do is factor out a n squared, okay? So we get 1 over 1 plus 1 over n squared times n squared. As n goes to infinity, this will become 0. Then this becomes, and then this actually gets cancelled out, so we get basically 1 over 1, which is 1. Or in other words, n squared plus 1 behaves just like n squared as n approaches infinity. Thus, we can write the following. As n squared plus 1 gets bigger, it is indistinguishable from n squared, right? So this will be n squared over n squared, which just gives you 1. So we know from this analysis that our actual limit now looks like this, okay? It's approximately like the function 1 times cosine of n. And now cosine of n should not converge because it is sinusoidal. In other words, our function cosine of n will never converge or diverge to some value because it continues going on forever. Alright, thus we get that this series actually diverges. Hopefully that made sense.